Good morning, everyone. Welcome back. In this video, I'm going to show you how to use the product property of logarithms. Okay, and what is a product property of logs? So the log of a product. So the log of a product. So A and B are two factors. The product they multiply together. Okay, is equal to the sum of the logs. So the log of a product is equal to the sum of the logs. So you're going to take the log of A and the log of B as well. It's the sum of log of A and log of B. And you also we call this format to go from one log to two log, like the expanded form. Okay. And to go from two log to a single log, we also refer to it as a condensed log. Okay, so what I would like us to do next, you're going to apply the property, the product property. Again, so if you have a log and within the log you have a product, it's going to be equal to the sum of the sum of the factor within that log. Okay. So let's have example number one. Okay, so number one is you're given log base 3 of 9 times x or 9x. So we are going from one log, and you want to end up with two single log, with two logs. So we call that the expansion. We want to expand the log. How do we go from one log to two logs? So again, within the log, we are given two factors. It's a product. Why? So if you don't see any operation between the two terms, always assume that's multiplication. So it's 9 times x. Okay, so 9 times, so log base 3 of 9x can be equal to what? So I can split that into two logs, and when I split that into two logs, it's going to be the sum. So I'm going to start first with log base 3 of 9, okay, plus log base 3 of x. Okay, so always start, the way you want to read it, you start with log, and then you say base 3, because the number at the bottom of G represents the base. And then you say log base 3 of 9. And here you read log base 3 of x. Okay, so now remember, log is the exponent. So when you see log, it's a fancy way for asking the exponent. Okay, so they're asking you, log represents the exponent. Okay, the number you write here will be the exponent you give to the base 3, so that the answer is 9. Okay, so what exponent would you give to the base 3? Okay, so that the answer is 9. Can the exponent be 1? 3 to the first power is 3. But you want 9. So remember, 3 squared gives us 9. So I can evaluate this log as being 2. So the exponent you give to the base 3, so the answer is 9, is 2. So remember, log is the exponent. So you have to give the exponent of 2 to the base 3, so that the answer is 9. So now here, since the x is an unknown number, there's no way to find out the number for the exponent. So you just rewrite it. Okay, and this is your final answer. So log base 3 of 9x can be written as 2 times 2 plus log base 3 of x. Okay, so let's do another example. Again, when you see the expansion, all you want to do here is, so to expand the log, so if you have a product, if it's a multiplication within the log, you're going to write it as a sum. Okay, so that's what I would like you to practice. Let's do number 2. So number 2, you have log base 6 of 7x equal to, so let's pause the video and tell me what would you write here. Okay, so instead of telling me, I hope you wrote this down. Okay, if not, again, 7 is multiplied to the x. So you will do, it should be log base 6 of 7 plus log base 6 of x. So that's the final answer. There's nothing else that can be done here. So this is your final answer. Okay. We could change, you could apply, if you want to find the exponent you give to the base 6 so that the answer is 7, we cannot do that in our head like we done here because it was pretty simple to find the exponent give to the base 3, so the answer is 9, which is 2. Here it will be a lot harder. And you have to apply the change of base formula because some calculator, you cannot find the, for most calculator, you cannot find the log of another base than 10 or e. So here you have to apply the change of base formula, and I'll show you another video how to use the change of base formula. For now, you just want to leave it alone. Okay, just leave it alone. Let's do another example. So number 3, you're given the log base 3 of 2 times x times y. Okay, so how would you expand this single log? So please pause the video and do that. Okay, and here's the answer. Okay, so let me give you another one, the final one, before we go to do the condensed form. One more. So please pause the video and show me, and please, I need you to expand this log. Okay. And here's the final answer. Okay, give me a second. So here you end up with, so we split into 3 logs because you have 3 factors. So log base 5 of 125 plus log base 5 of s plus log base 5 of t. So I know that log base 5 of 125 can be simplified to 3. Why? Because 3 represents the exponent you give to the base 5, so that the answer is 125. Okay, so the exponent is 3. And those 2 cannot be simplified, so you leave it alone. Those 2 logs cannot be simplified, evaluate. You cannot evaluate them, so leave it alone. Okay, and that's your final example for expanding a log. So the next phase, you're going to condense a log. What do I mean by condensing? So I'm going to give you 2 or 3 logs, and I want you to rewrite it as a single log, like this. So if you see the sum of 2 logs is going to be equal to the log of a product, okay, of those 2 terms, okay? So give me a second. So the first expression you're going to condense is going to be, okay, you're given the log, the common log of 5 plus the common log of 20. So how do we do that? So remember, so when you have a sum of 2 logs, we can rewrite it as a single log, and you're going to use a product, okay? So I'm going to rewrite as a single log. So I'm going to start with a log, the common log of, now parentheses, what am I going to write inside? So I'm going to take the 5 and the 20 and multiply them together. So you do 5 times 20, okay? And 5 times 20, so multiply to 100. So the common log of 100. So what is the common log of 100? So remember, log represents the exponent you give to the base, so the answer is 100. Uh-oh, so what is the base here? So this is a common log, so the base here is 10. Okay, if you don't see the base, then a number at the bottom of G, assume we are referring to the common log, and for common log, it's when the base is 10. When the base is 10, do not write the base 10. They assume, mathematicians assume, and we know, you know, and I know, that the number here, if you don't see the number for the base, is 10. Okay, so what exponent would you give to the base 10 so that the answer is 100? Can it be 10? Okay, so what exponent would you give to the base 10? Okay, it has to be, the exponent needs to be 2. Okay, So because 10 squared give us 100. So the answer is going to be equal to 2. So that's your final answer. So log base 5 plus log base, the common log of 5, the common log of 5 plus the common log of 20 is equal to 2. That was the final answer. So let's move on to another example. So you have log base, the common log of 2 plus the common log of 5 is equal to blank. So please pause the video and find out what these two, single log of these two logs equal to, okay? Okay, so again, you have the sum of two logs. So it's going to rewrite as a single log, and within the log, you're going to use a multiplication. And then here, 2 times 5 is 10. So remember, log is the exponent. So what exponent would you give to the base 10 so that the answer is 10? So the only exponent that will work is going to be 1. Okay, so basically, what exponent would you give to the base 10 so that the answer is equal to 10? So for both to be equal, since 10 is exponent is 1, so we have to give to 10 the base 10 1. So that's why I wrote 1 here. Okay, so let's do number 1. You're given ln of x plus ln of 2. Okay, how would you simplify this? How do you condense as a, how would you write those two logs as a single log? Please pause the video and do so. Okay, so remember you have the sum of two logs that share the same base, and remember ln means it's a log with base e, the natural number e. That's why you use the notation ln. Okay, so it's going to be the product. So the sum of two logs is going to be the product of those two number within the log. So x times 2 can be written as 2 times x. So ln of x plus ln of 2 equal ln of 2x. Okay, that's it. Okay, so I can give you one more. So the last one is going to be number 4. You're given log base 2, okay, of 32 plus log base 2 of 2 is equal to what number? Please pause the video and condense this log. Okay, so remember you have the sum. So it's going to be written as a single log, and within the log, you're going to use multiplication. 32 times 2 is 64, and 64 can be written as 2 to the 6th power. Okay, so 2 to the 6th power is 64. Now, remember, log is the exponent. So what exponent would you give to the base? So let me rewrite that here. So what exponent would you give to the base 2 so that the answer is equal to 2 to the 6th power? Okay, so the only number that you can give to the exponent so that both power are the same is to use the exponent of 6. So the exponent is 6. And that's the final answer. Okay, so thank you for watching my video. I hope my video was helpful to you. Have a wonderful day, and see you to the next one. Bye-bye.